This video is on Unit 5, Chapter 10, Intro to Rational Functions, Lesson number 3 on complex fractions. In your notes here, it says that a complex fraction is a fraction in which the numerator and denominator both contain fractions. To simplify a complex fraction means to rewrite as a single fraction with no fractions in the numerator or denominator. So basically, I have stated before that we are not allowed to leave fractions inside of a fraction. And in this lesson, we're going to learn how to fix these complex fractions. The steps to simplify, step number 1 says to create a single fraction in the numerator and denominator. Step number 2 says to set up as a division problem, then multiply by the reciprocal. And then thirdly, we want to simplify, factor first if possible. So looking at example number 1, there is, you've got one single fraction in the numerator and one single fraction in the denominator. And basically this is your dividing bar. So it says a over 2 divided by a squared over 4. What we're going to do, step number 1 does not apply. So we're going to take that top and we're going to write it as its state. We're just going to write it in a different way. So we've rewritten it as a division problem, and now we can do the keep it, change it, flip it, and do just like we did back in lesson number 1 and simplify these fractions. We're going to reduce 2 and 4 have a common factor of 2. So 2 divided by 2 is 1. 4 divided by 2 is 2. The A's are going to reduce. You have an A in the bottom. So we have 2 over A for our answer to number 1. Let's jump down to number 4. Number 4, we've got K minus 1 over K divided by K squared minus 1 over K squared. So again, the top divided by the bottom is going to change to keep it, change it, flip it. And then we may have to factor, cancel, reduce. Your K squared minus 1 is going to factor into a K minus 1 and a K plus 1. So I'm going to mark that out because I just factored it. So the K squared minus 1 is gone. I have factored it into the K minus 1 times K plus 1. Now you can see that your K minus 1s are going to cancel. The K in the first fraction is going to cancel with a K in the second fraction, leaving with K over K plus 1. In number 7, let's look at number 7. Number 7, we've got a fraction in the numerator, 15 minus 15r divided by 15r squared is being divided by 12r minus 12. So your denominator here is not really a fraction, but I'm going to make it a fraction by putting it over 1. And again, we're going to rewrite that as 15 minus 15r divided by your 15r squared. And that's being divided by your 12r minus 12. But again, we'll keep that over 1. So then we can do the keep it, change it, and then flip it. And then we're going to have to factor. So the first fraction in the numerator, there's a GCF of 15, which is going to give me 1 minus r. And the denominator on the second fraction, there's a GCF of 12, and I get r minus 1. Now, 1 minus r and r minus 1 are not the same. They are opposites of each other. So if I had taken out a negative 15 instead of a positive 15, then I would have negative 1 plus r. And now those two are the same. The negative 1 plus r and the r minus 1 now actually match. I'm going to cross out that 12r minus 12. And then I can continue to reduce here. So the 15 in the top and the 15 in the bottom are going to cancel. So I got a -1 here in that numerator. And it looks like that's it. So I have a -1 in the top and a 12r squared in the denominator. So there's your answer to number 7. Let me do number 8. Number 8 says 2m squared minus 2m minus 40 divided by 3m plus 12. And that's being divided by your m to the third minus 5m squared divided by 9m squared plus 36m. So most of you are probably at this point wanting to skip the whole writing it as a division problem, because you can rewrite this in one step. So we got the 2m squared minus 2m minus 40 over the 3m plus 12 times, flip that fraction, and now we need a factor. There's a lot of factoring in this one, I think. I'm going to start in the second fraction. So in that second fraction, there's a GCF in the top of 9m, which leaves me with m plus 4. So that's now gone. In the denominator of that same fraction, I've got a GCF of m squared, and that's going to leave me with m minus 5. So I've fixed that. Your 3m plus 12 has a GCF of 3. Now, your numerator, I saved the best for last. Your numerator has a GCF of 2. So that's going to give me 2 times m squared minus m minus 20. And we still have to factor that. We still have to factor the m squared minus m minus 20. So we're looking for two numbers that multiply to give us -20, that add to give us -1. -20, -1, which would be a -5 times 4. So because the leading coefficient is a 1, that's going to factor straight into, keep your 2, m minus 5. Hopefully you can see this. I've run out of room here. So that factors again into your m minus 5 and your m plus 4. So now what we want to do is we're going to go through and we're going to start canceling. So your m minus 5s are gone. Your m plus 4, whether you want to cancel that bottom with its top, totally up to you. 3 and the 9 are going to reduce. The 3 becomes 1. 9 becomes 3. And then the m cancels with an m in the denominator. Got an m there. All right, I think I've got everything canceled that can cancel. I'm going to go through and circle. So I have a 2 left, and a 3 left, and an m plus 4 left, and then an m left in the bottom. So I have a 6, and an m plus 4 in the top, and just an m in the bottom. And there's your answer for number 8. So that was a lot. Didn't really fit in that little box. Hopefully you were able to kind of keep up with everything that I did. All right. So that brings us to the second page. So on the second page, what you're going to notice is inside these fractions, we don't have just single fractions. So look at number 9. The numerator has got 2. So in these complex fractions, what you have to do first is kind of go to the side and figure out how to make those 2 1. And then do your keep it, change it, flip it. So I'm going to go to the side here. I've got my x over 3 minus 3 over x. And I've got to condense these into 1. Now, it uses the what you learned from lesson number 2. Right now, I cannot subtract these two fractions because they do not have a common denominator. So I need to create a common denominator, which in this case would be a 3x. The first fraction is going to multiply by x, and I have x squared. The second fraction is going to multiply by 3, and I have a 9. So I just changed those two fractions, and now I can subtract. It becomes x squared minus 9 over 3x. So that is my new numerator. So it looks like this. Okay, and we're going to do just like we did on the first few. We're going to keep it, change it, and flip it. Then to simplify, you want to factor anything that can factor. So the x squared minus 9 is going to factor into x plus 3 and x minus 3. That is your difference of squares. So x plus 3 and x minus 3. And then at that point, your x minus 3's will cancel. And the x's will cancel. So I have an x plus 3 over 3 for the final answer on number 9. Now, some students may try to cancel those 3's, but remember, they do not cancel because the 3 in the denominator is a monomial. The 3 in the top is part of a binomial, and we can never, ever, ever cancel those kinds of things. So I'm going to do let's do number 12. Number 12, I've got w over w plus 2 divided by 1 minus w over w plus 2. So in this example, the denominator is our issue. So I need to, again, there's two fractions. As soon as I put that over 1, there's two fractions. I need to make it 1. So the common denominator here, if I've got 1 over 1 minus w over w plus 2, I'm just looking at my denominators, and I got a 1 and a w plus 2. So w plus 2 would be your common denominator. The second fraction is not going to change. So in this first one, we would need to multiply by w plus 2. So basically, I've got a w plus 2 in the top, and then I'm going to subtract w. So I get just 2 over w plus 2 for my new denominator. So I'm going to keep the top, change it to multiplication, and flip. So this is my new denominator. I'm going to flip that, and I've got w plus 2 over 2. And then the w plus 2's are going to cancel, leaving me with just w over 2. Now let's do another one. Let's do number 16. Number 16, I've got a squared over a plus 3 plus a squared over 5a plus 15. That's just my numerator. And then in my denominator, I have two more fractions. So basically what we have to do here is fix the top and the bottom. So let's look at just the top first. A squared over a plus 3 plus a squared. I'm going to go ahead and factor that denominator so that it's easier for me to tell. My common denominator is going to be a 5 and an a plus 3. In that first fraction, I just need to multiply by 5. So I have a 5a squared to the top plus. The second one is not going to change. And this is going to give me 5a squared plus another a squared is going to be 6a squared over the 5 times a plus 3. So that's my new numerator. That's the one I'm going to keep. I'm going to change, and then I'm going to flip the next one, but I got to fix the denominator. I got to fix the denominator before I can flip it. So I've got an a over a plus 3 plus 1 over 5. Well, looking at those two denominators, my common denominator needs to be a 5 and the a plus 3. Which In your first fraction, you're going to multiply by a 5. So 5a plus the second fraction, we need to multiply by a plus 3, which is just going to give me an a plus 3 in the top. So my new numerator, 5a plus a is 6a plus 3 over that common denominator of 5 times a plus 3. And I'm so out of room down here. So there's my new denominator. I'm going to flip it. So my 5a plus 5 times a plus 3 is going to cancel. The denominator on that second fraction needs to factor. There's a GCF of 3. Because the way it was, I could not cancel. That's a binomial. I couldn't cancel anything from that 6a plus 3. But now I can cancel the 3 and the 6. 3 goes into both 3 and 6. 3 divided by 3 is 1. 6 divided by 3 is 2. So I end up with 2a squared over 2a plus 1. So there are your notes on complex fractions for lesson number 3.